All right. Advanced Algebra, Topic 7, Chapter, sec, Topic 7, Section 5. So we're finally going to get into the factoring. And I have a list of questions that I go through when I'm factoring. And not honestly, we don't need this whole list right now, but we will at some point. The first thing I ask is there a greatest common factor? And if there is, then we factor that out. The second question I ask is it binomial? And if it is, we have a certain way to factor a binomial. And then the third question is it a trinomial? And if it is a trinomial, then what I like to use is something that I call a factor puzzle. And last year, I don't think I taught the factor puzzle. I just taught process of trial and error. And then my pre-calculus kids were talking to me, and some of them still use a factor puzzle. So they suggested that I teach the factor puzzle rather than just the trial and error method. So that's what I'm going to do here. The factor puzzle looks like this every time. And in a quadratic trinomial, like x squared plus 3x plus 2, this is called our quadratic term because it's raised to the second power. This is called our linear term because it's raised to the first power, the x, and this is our constant. Obviously, because there is no variable there, or if there is, it's 0 power. The quadratic term always goes here, the constant goes here, your term goes here. And this is how it works. So, draw my 3 lines. Okay. Quadratic term goes here, the constant goes here, the linear term goes here. And when we factor these things, we want to make sure they're in standard form before we. So, what are the factors of x squared? Well, x times x. I don't have a lot of choice there. What are the factors of 6? Sometimes I go off to the side and I actually write them down, either 1 and 6 or 2 and 3. Both of those would make 5. But I happen to know that 6 and 1 won't work. Because if I do 6x and 1x, 1 has to be negative. When I check it, negative 1 times 6 is not positive 6. So even though 6 and 1 could make 5x, it's not going to work for when to multiplying it together to get 6. So I put 2 and 3 in our charts, multiply across, multiply going this way, multiply going up, okay, multiply going that way, and then in this column over here, we add going down. So I multiply across, I get 2x and 3x, and 2x plus 3x is 5x. So it works. So my answer for all that is x plus 3 times x plus 2. And I write it out. X plus 3 times the quantity plus 2. That's how that will factor. Okay. So, and some people can do this in their head, no problem, without a factor puzzle. That's great. Factor puzzle always works for me. And as I said, my kids in pre-calculus still use it when they're factoring. Quadratic term goes here, constant goes here, linear term goes down here. So this is x and x. Let's see, 1 times 36, 2 times 18, 3 times 12, 4 times 9. There it is. 4 times 9 works. So this is 4x, this is 9x. And I check everything. 4x plus 9x is positive 13. 9 times 4 is 6. X times x is x squared. So my answer is quantity x plus 9 times the quantity x plus 4. Write that out like that. This one, and we actually were finishing up this in Algebra 1, and they did very well with it using the factor puzzle. One student tried not using the factor puzzle, got a lot of the problems wrong, so we quickly switched over to using it. So x squared again, it's x times x, 28, 1 times 28, 2 times 14, 4 times 7, 4 times 7 is going to multiply across, and then we check it. That plus that equals that, times that is good, that times that is good. So answer is x plus 7, quantity x plus 7 times the quantity x plus 4. Okay. The last one on this page. X squared, 15, make sure the sign comes with that. X squared, x times x. Eventually we'll put a number in front of here, and that'll be different. That'll change the number of permutations that could be possible to make this work. 15 is 1 times 15 and 3 times 5. So obviously it would be 3 times 5, and we multiply across, and that does not work. But it would work if the 3 and the 5 were both negatives. And so that's what we do. We make those both negative, and then we check it. That works. Negative 5 times negative 3 is positive 15, and negative 3x plus negative 5x is negative 8x. So again, my answer, quantity x minus 5 times quantity x minus 3. And it is imperative that you go diagonally to get those answers. Okay. So a whole bunch of examples here. X squared goes here, 42 goes here, negative 13x, our linear term. And let's see, x times x, 1 times 42, 2 times 21, 3 times 14, 4, does 4 go in? No. 5, no. 6 times 7, that's what we need. So 6 and 7, multiply across, and looks like they both need to be negative in order to make this work. And then we check it, yep. So x minus 7 times x minus 6. This one now, the negative is on the constant, so that's going to make things a little bit different. X squared, negative 6 goes here, positive 5x down here. So let's see, x. Again, it's 1 and 6 or 2 and 3. I don't think it's going to be 2 and 3. Just because to be 2 and 3, they would both have to be positive, and that's not going to work. So I try 6 and 1. I multiply across. And in order for me to get positive 5x, the 6 needs to be positive, and the x needs to be negative. And then when I check it, x times x is x squared. Negative 1 times 6 is negative 6. And 6x minus x is 5x. So my answer, the quantity x minus 1 times the quantity x plus 6. And that is factored. I hope you could hear my puppy crying, but she's crying. She wants my attention. She's being a naughty girl. My mommy's trying to do her work. Okay? You're being naughty. That's a big truck. Alright, come on. Now she's trying to sit in my arms while I make videos for you guys. Train wreck around here. So quadratic term goes here. Negative 14, make sure you put the sign with it. Negative 5x. So again, don't have a lot of choice there. 14 is either not 1 times 7, 1 times 14, or 2 times 7. And I think it's going to be 2 and 7, 2x, 7x. And we need to figure out which one needs to be negative to make this work. One of the biggest mistakes I see, especially in my Algebra 1 kids, is they want to put the sign on when they write these numbers down. And that's a big mistake. You figure out the sign over here, not before that. Because 9 times out of 10, they get it flipped around. Okay, so obviously over here, it's obvious that the sign needs to be on the 7. The negative needs to be on the 7 in order to get, 2x plus negative 5x is, or I'm sorry, 2x plus negative 7x is negative 5x. And so the sign, the negative over here needs to be on the 7. And so then our answer is the quantity x minus 7 times the quantity x plus 2. Oh my goodness. Good thing I don't teach from home. Factor puzzle. X squared, negative 16, 6x, x times x, 4 times 16, 2 times 8, 4 times 4. It's going to be 2 times 8. It's the winner. So multiply across 2x, 8x. To get a positive 6x, I need the smaller one, which is the 2, to be negative. So this is the quantity x plus 8 times the quantity x minus 2. Now this crops up periodically where we have an x and a y variable. And to be completely honest, I wasn't completely honest with you before, the quadratic term and the constant are technically interchangeable. I always want to write in standard form, which means my quadratic term is always going to go here. Okay, and in standard, for this to be in standard form, we would write it in descending order of the variable that comes first alphabetically. So I'd write it in descending order of the x, and so that way my quadratic term always comes first. Okay, and so here where I have 2 quadratic terms, that's the actual quadratic term because it comes, x comes before y in the alphabet. This is 24y squared over here, and this would be 10xy down here. So again, x times x, 24 is 1 times 24, 2 times 12. 2 times 12 could make 10, but everything here is plus. So I don't think it's going to work. 3 times 8, 4 times 6 makes 10. Now instead of just writing 4 and 6, I'm going to write 4y and 6y. And when I multiply across, I get 4xy and 6xy. And when I check it, I add down, that works. That times that, everything works. So my answer is x plus 6y, quantity x plus 6y, times the quantity x plus 4y. And Same thing, my quadratic term, it's in standard form, so my quadratic term x squared, the other quadratic term, or not really, 32y squared, 12xy goes down here. Now, if for some reason I couldn't get this to factor, then I would say that this is prime. 4 times 8, I think 4 times 8 will work, so 4y, 8y, 4xy, 8xy, 12xy. So the quantity x plus 8y times the quantity x plus 4y. And last example in that, then we'll move on to the story problem. We have, what am I doing? In standard form, so x squared goes here, 21y squared goes here, negative 10xy down here. So let's see, x, 21, I don't have a lot of choices. 1 and 21, 3 times 7. It's obvious that 3 and 7 are going to make 10. 3xy, 7xy, that doesn't work. But if I make them both negative, it will work. So I'll make these both negative. So the quantity x minus 7y times the quantity x minus 3y. There's a little girl walking in front of the house that is an imminent threat to our yard and driveway. Obviously, it's not as imminent a threat as what Russia is to the Ukraine right now, but Bella thinks it's very serious, and that's why she is sounding the alarm and making sure that that little girl does not trespass into our yard, because that is Bella's job. Anyway, as I said, it's a train wreck around here today. We move on to this little story problem that has 3 parts to it. Basically, we have a lake, and the lake has a shore, and they have a roped off rectangular area that is for swimming so that we don't have a boating accident with a swimmer. And so the area of this section is x squared plus 3x minus 40. And they want to know what are the possible dimensions of the roped off area. Well, to get area, I multiply something times something. And if I have a trinomial, I know that it came from a binomial times a binomial. So basically what I can do is factor this thing. So x and x, 1 times 40, 2 times 20, 3, 4 times 10, nope, 5 times 8, yep, there it is. And so 5x, 8x, I want the 3 positive, so I need the 8 positive, which means the 5 is negative. So that works. That's negative 40, positive 3x. So x plus 8 times x minus 5. And then they tell us that the longer side is the one that's parallel to the shore. So that means that of the 2 dimensions, this one is x plus 8, and this one is x minus 5. Then they ask, well, how much rope do we need to rope off this area? And I hope they don't use just rope. I hope they put some floaty things on there. And so that's perimeter. They're asking for perimeter. And to find perimeter, I add up the length of each side. So x minus 5 plus x plus 8 plus x minus 5. And I get 3x minus 2. And then they go ahead and say, well, here's how much rope we have. So what can the dimensions of the swimming area be? Well, the perimeter then is 238. I would add 2 to both sides to solve this. 3x equals 240. Divide both sides by 3, and x is 80. So the dimensions would be, if x is 80, the dimensions would be 88, and leave myself enough room to write, but this would be 88 by 75, and we're talking feet. So I should have put 88 feet by 75 feet. Okay. Hopefully, before the next video, I can get my dog settled down. The little girl will vanish from the front of our yard, and everyone will be safe.